A lot harder than I expected. Yeah, it's not gonna. Whatever. For anyone in the meeting, if you could please sign in. Why isn't it? Holy shit. Oh wait. There we go. See how many people do we have in the meeting? I think we'll get started in like 1 minute. Yeah, I'll make them go. There we go. So Logan, I made you a co-host, so should be able to screen share in a second. Thanks. I think I should have just started.
I'm ready to share whenever you're ready for me to take over.
Okay. Should I wait a few minutes or do you think?
We can wait till 12:04. How about that? Or what? 12:05. It's up to you. True. I'm really hoping the leak code thing. Yeah, 2 weeks from now.
It's gonna be online at learning.
The leak code thing?
No, the code. Or we doing
It would be in person. So I just literally have like groups set up in here. Wait, what?
I need the schedule for that.
Yeah, we're gonna start at 12:05. I think we still have the same. Is it all good? Okay.
Yeah, we could just have like 5 minutes of answer before we start.
Okay, I guess we'll just go ahead and get started then. Unfortunately, Keaton is not here due to a doctor's appointment. We hope he's doing okay with whatever he's getting checked up on. Thank you guys for coming to see Logan and his workshop on Julia. And thank you, Logan, for being here. I know you've been here in the past, so yeah, thank you again. And I think we have a quick announcement, which is just, of course, please sign in to the sign-in sheet, especially for people on Zoom. And then also, if you guys could please fill out that shirt interest form that we announced in the Discord. Please fill that out. Do we have any other announcements? I think that's pretty much it for announcements. I think I'll just give it to you, Logan. Should be able to share your screen.
Awesome. Cool beans. I am sharing now. Is it all good coming through okay?
It looks good.
Cool, wonderful. Well, thanks for having me again to chat about Julia stuff. And for folks who aren't familiar, my name is Logan Kilpatrick. I'm the developer community advocate for the Julia programming language, and that's sort of my open source role. I do a bunch of other stuff, like I think I'm actually presenting about my full-time job, which is at Path AI, where we use machine learning and deep learning to help improve cancer patient diagnoses as well. So lots of fun topics, but today we're talking about the Julia language, which is an open source programming language. I'll give you a sort of high level of what we'll run through. I'll give folks context on what Julia is, talk about some of the relevant features that I think make Julia sort of a viable candidate for folks to consider using as a programming language. We'll look at some data science stuff just because it's one of the hottest fields and sort of an area where Julia is excelling as an ecosystem. And I'll also give folks advice and suggestions on how to get started actually contributing to the ecosystem. If you're interested in diving in and making some contributions during something like Hacktoberfest or the like, I'll give you all the good links. So I always like to start off with this question, which is, why do we need another programming language? And I think the historic context for this as to why Julia itself was created was, at the time, back in 2012, you had high-level languages like Python, which were really easy for developers to use and have actually gotten much easier for developers to use over the last 10 years. But then you had low-level languages like C++ and C, which were less user-friendly. And if folks have taken a C++ or C class, they might have learned this from first-hand experience. Dealing with pointers and all those kinds of things is much more challenging than the way that you would develop code if you were doing Python. So you have this speed versus usability trade-off that developers have to make. And in sort of production, professional environments, when you go and actually, if you go get a job at Tesla or something like that, doing machine learning or data science, a lot of the prototyping work that happens in production environments is done using Python. And then when you want to take a model into production or take some workflow into production, you actually rewrite the code in a lower level language like C++ or C in order to leverage the speed requirements that are required for production settings. And obviously, there's tools out there that help sort of try to bridge this gap, like Python and a bunch of other things in the Python ecosystem, but there's limitations on what type of code you can actually write if you're using one of those tools. So Julia was created to solve this two-language problem, which is, again, the trade-off between speed and usability. So Julia is as easy to use as something like Python from a syntax perspective, but it has speed characteristics that are similar to C and C++. So you can really sort of get, in a lot of cases, orders of magnitude improvement in the execution time of your code by writing it in Julia. Tons of other pieces of this. Just for context on how large the Julia ecosystem is, I think we're coming up on, I think at the end of last year, it was something like 40 million downloads of Julia total. So it's a large development community. With respect to packages, we're getting close to the number of packages that the R ecosystem has now, which is usually one of the indications that people look at as far as the health of an ecosystem. So it's, Julia is being taught all over the world at hundreds of universities. All these things are great signs for us in the ecosystem. I'll touch on two other really quick points that I think distinguish Julia as a language from a lot of the other things that are happening in the space. Interoperability is a critical idea, and I think I'm not sure if folks have come across this challenge or not in their own sort of professional careers, maybe at internships or in projects and classes and things like that. But in sort of the sort of industry context, people use different tools to solve different problems. So you might join a data science team or an engineering team, software engineering team at some company where, a bunch of people did stuff in R to do data analysis because that's what they, took undergraduate classes in. A bunch of people are doing stuff in Python. Maybe there's some other tools like C++ or something like that you're using for production environments. And it becomes a huge challenge for you as a developer to not only have a grasp on all those tools, but also sort of glue them together. And this is actually one of the cool things that Julia does well, which is we have this extensive interoperability ecosystem where you can actually call C++ code, you can call Python code, you can call MATLAB, R, Java, directly inside of a Julia file. So you're able to sort of stitch together some of these disconnected and sparse things in the ecosystem, which allows you to build on top of what you already have without having to write everything from scratch. So if you're thinking about like step one in building a programming language today, I would tell anybody that step one in building that programming language is making sure that you have this interoperability, because the genuine reality is, if you go to 10 million software developers in the world and you say, hey, we have something that's better, and by the way, you also have to rewrite all of your code from scratch, nobody is going to adopt whatever that tool is. It doesn't matter if it's twice as fast. It doesn't matter if it's easier to use. People don't have the time to to rewrite all their stuff from scratch. So that's where the interoperability component is extremely critical. And I think the Julia ecosystem has done a really good job of this and making sure that it's the ecosystem is viable through this interoperability. The other piece of this is the community is massive. I love the Julia community. I think I'm fortunate enough to get to work and advocate on the behalf of the Julia community all the time. There's so many smart people solving some of the most interesting problems related to climate science, a lot of medical challenges, drug discovery. All of these things are being done using Julia, and that's really sort of the state of the art in the ecosystem. The people on the bleeding edge who are solving these problems are using Julia. And from my personal experience, these people are always willing to actually help you learn the language, learn the ecosystem, how to leverage the tools, all that type of stuff. So it's super exciting. And I would encourage folks to, even with all the technical stuff aside, I think if you're trying to build a career and build sort of your technical background, I think being involved in a community like Julia, and it doesn't have to be Julia specifically, but it's something that's like Julia, where it's a little bit smaller than some of those like broad Python communities, for example. And folks are willing to invest the time into those relationships, which I think is really cool. And we talked about the speed, and we'll talk a little bit more about reproducibility in a second, but those are the high level sort of arguments that I wanted to make before we dive more into the details. And I'll also just pause here to say that if folks have questions, I actually can't see Garrett. I don't know if there's people in person who are watching this, or if everyone is on Zoom, but you're welcome to raise your hand or just totally interrupt me. I'm happy to take questions as folks have them. You don't have to wait until the end.
Yeah, no, of course. I'll let you know if someone in person has a question.
Cool, awesome.
Yeah.
So we talked about a lot of this stuff already. I think the reproducibility aspect is super critical, and I don't know if folks have experienced this again personally yet in their sort of development career, but like you'll 100% at some point run into a bunch of challenges with Python packages or with other reproducibility in other languages, where somebody sends you their code and you're unable to reproduce the results because the package sort of system isn't optimized for you to do so. And I run into this challenge all the time with running Python code and certain packages not working the way that I would expect them to, et cetera, et cetera. This fundamentally comes down to the package ecosystem and the way that the packages are managed. And the Julia ecosystem, we'll see, I have a demo of this in the slides later on, but the Julia ecosystem has really solved this problem, which I think is incredible. So as a developer, when I'm writing Julia code, I never really have to worry about the reproducibility aspect, because the way that the infrastructure for the packages is set up is set up such that it solves this fundamental problem that other languages have. And you can sort of the way to think about this challenge, and the reason that it's there, is because if folks are familiar with Anaconda, the business, and Conda the business, or Conda the package manager, Anaconda as a business was literally created because it was so hard to manage your Python packages. So they have a multi-million-dollar a year business just on the fact that the built-in Python package manager and the ecosystem to manage packages in Python wasn't sufficient for developers to actually use effectively. So they had to build a commercial company. They sell enterprise products, et cetera, to solve this problem specifically. And it's wonderful that in the Julia ecosystem, people saw this and they just solved this problem out of the box. So default Julia comes with a package manager that's open source and just works for a lot of these problems, which enables this reproducibility, which is really cool. So all of this is fine and interesting, but I think the cool part of thinking about a lot of this stuff, and give me 1 sec to mute my mic. the grass gets cut at my house every other week, and it's always very conveniently timed to when I'm in a meeting trying to present something. And for some reason, the landscaping people also stop right in front of my window to like reposition their stuff. So apologies if there's some background noise. But what I was going to say is, so all the stuff about the ecosystem and the language at a high level is great. But what I think is, again, when I mentioned this before, some of the most compelling stuff is the actual problems that Julia is being used to solve. And I think one of those problems is in the climate space. The Climate Modeling Alliance, CLIMA, based out of Caltech and NASA's JPL down in Pasadena, is one of these projects that's using Julia at a huge scale. And basically the idea is they need to build climate models that are sort of up to the scale of the entire planet. And if folks have done any like fluid dynamics or any sort of modeling and simulation before, just modeling like the water, like a drop of water in a piece of like glass or something like that, is extremely difficult to do. And you can imagine like climate modeling is that on the scale of the entire planet, and you're trying to model all this stuff, and it's extremely complicated, takes a ton of compute, is a really computationally difficult problem. And the folks at CLIMA made the decision to use Julia from the ground up to do all of their development because of the scalability of the language, because of the speed and execution. And they can feel comfortable knowing that, you know, they're making an investment in an ecosystem that's going to continue to be as fast as they need it to be. I'm just looking at the chat right now. Okay, cool. Just the sign up form. So another great use case, and again, apologies for the background noise, that I think is fascinating is actually the FAA. So if folks are familiar, the FAA actually helps make it so that they provide a lot of the infrastructure for collision avoidance to make sure that planes don't fly into one another when they're out in the sky. The actual infrastructure to make that happen within the FAA was written in Julia and was produced. A lot of the work is using POMDPs and MDPs and under the field of decision making under uncertainty. If folks aren't familiar, there's a lab at Stanford, the Stanford Intelligent Systems Lab, and they actually develop a bunch of the core packages that this project uses in order to do a lot of the collision avoidance stuff that they do. So every time you're flying on a plane, you can think about the FAA is keeping you safe using Julia, which I think is super cool. And this also speaks to I think the maturity of the ecosystem. Like the FAA has been using this system for years now, and they made what I would say is a bold bet on Julia as an ecosystem in order to sort of invest and actually use this to keep people safe, which I think is really cool. One other quick example, which I think is much less grandiose than the CLIMA project and what the FAA is doing, but I think also has, you know, a ton of merit and sort of drives home the point that people are using Julia today to solve real problems. And the Boston School District is one of those things that one of those groups that's using Julia. They have a whole project where they ended up saving like $18 million and were able to make school start later in the day, which I think we can all appreciate as students or former students, simply because they were able to optimize the bus routes using Julia, which I think is a really cool use case. So if you want to go to school later, try to convince Cal Poly and some of the other institutions that you all are familiar with to use Julia to somehow optimize the class schedule or something like that. Lots of other cool use cases. I'm happy to, like, I started using Julia when I was working at NASA, and the team that I was interning on happened to be using Julia. So happy to talk about that experience if folks have questions or want to hear about other use cases. But hopefully sort of the takeaway from all of this has been that Julia as an ecosystem and as a language is something that's worth trying. And if I haven't convinced you yet, I think hopefully what we talked about in the next few slides will convince you. So let's say I have convinced you and you're like, I'm ready to start. I want to learn more about the ecosystem. One of the things that I would suggest is there's a really great course at MIT, which is probably right up the alley for a lot of folks here coming from a computer science / computational background. And this course is totally free. It's available to the world. It's called Computational Thinking. It's an introduction to computational thinking, and the URL is computationalthinking.mit.edu. If folks are familiar with YouTubers like 3 Blue 1 Brown, Grant Sanderson, who makes all those like amazing educational math videos, he's actually one of the co-creators of this course at MIT with Alan Edelman and some other folks. So he's like one of the lecturers, talks about Julia stuff, lots of cool things like that. So it's a great collaboration and partnership. The videos are amazing. I would highly encourage folks to check it out if you want a sort of entry point into the Julia ecosystem and you want something to learn like a traditional academic class. Talk about some of the things that I think are cool. One of which is the package manager, and we've sort of, I touched on this before, but let me play this video really quick, and hopefully it's not too laggy. It looks like it's lagging on my end. I don't know why it's so, let's see if it'll play. Probably because I have Slack open and Google Chrome and all the things that just eat up memory on my computer. And 6 VS Code windows. Let's see. Come on. It might not play for us, but it's a video showcasing sort of what the interface for installing packages looks like, and I maybe actually can show a different example of this. Let me, oh. All right, can folks still see this? Just to give a very live demo.
Yeah, looks good.
All right, so we're in the Julia terminal in the REPL, where you can, just similar to like the Python interpreter, you can like run basic commands like 1+1, yada, 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 print stuff. So this is just like the interpreter if you're familiar with Python. But one of the cool things is that the Julia REPL, the Julia interpreter, if you want to think about it that way, has a built-in package manager, which I think is super helpful. So if you type a left-facing square bracket in Julia, you enter into the package manager, and then I can type something like the word status, and this will tell me, it'll point me to the file that's managing all of the dependencies of my current environment. And it'll also show me what packages I have installed. So right now I have the Flux package and the OpenAI package, which are used for deep learning stuff. And I can go ahead and add something like plots, which is the Julia plotting package. And it goes through and it does all the stuff for installing it. And let's see if this does things quickly or not. Hopefully it'll be fast. But this workflow is genuinely one of the things that I appreciate the most about developing code in Julia these days. It's just so easy and convenient to get my package situation managed and actually understand, like, how do I switch between these different environments? And I'll show one other example once this is done compiling all the stuff that it needs to. All right, so we finished installing a new package. We can type the word status, and now I can see I have plots here, et cetera, et cetera. If I wanted to create a new packet or a new sort of environment to work in, I could activate the present working directory that I'm in. So now I'm in the default folder is like my root home Logan Kilpatrick folder. So now I could type the word status again and see that I don't have a project file in this current folder that I'm in. So it's telling me it's empty, but I could go and install new packages. And then all I have to do is send somebody this project.toml file, and then they can type the word instantiate, if I spelled that right, instantiate. And they would be able to, again, install all of the dependencies that come in this project.toml file directly into their present environment. So they don't have to worry about like making sure they install the right versions. You get somebody's code, it has a project.toml file, you type the word instantiate, and you're good to go. It automatically downloads all the correct versions with the right dependencies, and you can just start running your code. And again, this is a fundamentally different, like the ideas are the same in the Python ecosystem, for example. Like you can download you can send someone a requirements.txt file, but like the way under the hood that a requirements.txt file works versus a project.toml file is completely different, and you're more likely to run into those challenges with getting things installed because of some of the background stuff that happens with requirements.txt files. So just a contrived, probably not that great, hopefully illustrates a little bit of the point, which is reproducibility in the package manager. And again, happy to answer questions if folks are confused or want more context on this example. So apologies if that didn't make any sense at all. But I'm going to switch back to these slides. So let's talk a little bit about some of the data science stuff, because I think that's why a lot of people are using Julia today. And it's also one of the hottest fields for jobs and what students are learning and all that good stuff. So when you think about the benefits of data science in the context of the Julia ecosystem, one of the biggest things that you'll see is just out of the box performance improvements for a lot of the basic tools. Like if you're familiar with doing anything like data science related in Python, for example, you're going to be using pandas to sort of handle data frames and all that kind of stuff. So that's sort of the traditional workflow in the context of Python. In the Julia ecosystem, we have dataframes.jl, which is the Julia package to handle data frames, which is the same, it fills the same need as pandas does. But out of the box, it's an order of magnitude faster, which means that you can more effectively work with large data sets and just do the everyday tasks that you want to analyze data in sort of a simpler way. Again, we talked about interoperability before, but it's a huge thing in the data science ecosystem. People write their models in whatever language, using whatever package and tool. There's so many these days, and you can just directly call and use those packages and those models in Julia, which is really cool. Writing and reading CSVs in Julia is also extremely computationally efficient. It's another, when you're working with data, common data sets and things like that come in CSV format. You can read that in 10 to 20 times faster. And you can imagine for a data set that has millions of lines of data, it might take 5 minutes or something to read in, and you can do that in 10 to 20 seconds in the Julia, using the same tools in Julia, which I think is a huge value add for people doing data science. You can save that time for focus more on the things that are actually important. So one thing that I always love to add is you sort of don't have to take my word for a lot of this, that Julia is a viable candidate for use in the data science and machine learning space. One of my favorite people, not because he says good things about Julia, but just in general, because he's got great ideas, is Jeremy Howard, who created Fast AI. And he's a huge supporter of the Julia ecosystem. And I linked this interview he did with Gradient Descent through Weights and Biases, but he talks a lot about why Julia is actually really well suited to be the future language for machine learning and data science because of the fundamental limitations of the Python ecosystem. And we'll talk in a second about what some of that looks like in practice, but just wanted to point this as a resource for folks. If you just Google why Python's not the future of ML, Jeremy Howard, you'll find the link to this talk, which I think was really compelling when I read it. Another thing that I would love to highlight for folks is this was a post from one of the core PyTorch people and one of the core PyTorch developers, which is one of the most popular machine learning frameworks that folks use today. And it's titled Where We Are Headed and Why It Looks a Lot Like Julia, but Not Exactly Like Julia. And basically the gist of this entire post is that all of the technical things that Julia, the ecosystem and the language have done are the things that the PyTorch ecosystem really wants to be able to do. And they've copied a lot of the same ideas. The only reason they haven't rewritten PyTorch or rewrote a version of PyTorch using Julia is because there's such a large ecosystem built around Python. The interesting part of it is that if folks have used PyTorch before, or a lot of these other machine learning frameworks, it's often presented as, you know, it being a Python package. Like when you think of PyTorch, you're like, it literally has Py in the name, so it must be all Python. As soon as you peek under the hood of any of these machine learning packages, you actually realize it's not Python. The packages are not written in Python. There's the underlying code is all written in C++, and you can see an example here. One of these is PyTorch on the right. The other one is TensorFlow, which is another popular machine learning library. And they're actually written in C++ with in some cases Fortran and some other stuff under the hood. They just have a Python wrapper on top, a Python API for developers, because nobody wants to write C++ code, bar a few exceptions. And if we contrast that with the Julia ecosystem, Flux is Julia's deep learning package, Julia's machine learning package. And it's written from the ground up in 100% Julia. So if you understand as a developer how to use Julia, you can now directly go and see, how does Flux create a deep learning package from the ground up? All of the code is in Julia, and you can understand all the code, because one of the things that folks say in the Julia ecosystem is the line between developers and users is really blurry. Like if you can write basic Julia code, you can go and read other people's code that's out there and actually write packages for people to use. And you could think about this in the context of the Python ecosystem. Like I've learned Python before. I know how to program in Python. I've done it in my career and school before. I want to go and contribute to PyTorch. Well, the reality is there's actually a limited set of things that I can contribute to PyTorch in Python because the underlying code is written in C++. So now as a developer, I not only need to understand all the Python stuff that they've done, but I also need to be an expert in C++ in order to make a contribution to this project, which I think is one of the barriers to entry for folks who are trying to make these contributions. So something to think about as far as whether or not something that makes Julia valuable as an ecosystem. And the other interesting thing is the actual core language itself is written in Julia. So like you can understand how like all of the basic functions work in the language and things like that, because it's all Julia code that's been written in Julia itself, which is super cool to see. Two other really quick resources, articles that I wrote before, just for folks who might be interested. You can Google why you should invest in the Julia community now, and it's a couple of articles where I just give more context, more depth to a lot of what we've talked about today. So if you're not convinced yet, or you want additional resources, another one was why you should use Julia for machine learning. The last sort of quick plug that I'll make is JuliaCon is the annual Julia conference every year. All the talks from the conference are available online. So if you're deeply involved in like research in like a very specific area or something like that, and you're like, well, I want to know what the resources are for, you know, the domain or discipline that I'm interested in, JuliaCon is probably where you're going to be able to find those talks. So if you just Google whatever it is, like biomedical data science JuliaCon, any of the talks that folks have done in the past will pop up, and usually it's super high quality content. So would suggest folks leverage that if you're interested. Any questions? Again, sorry, I'm talking too much.
I don't have any questions here, but I mean, first off, I'd like to say that was a great presentation. Thank you.
Yeah, sure.
It's hard enough to like learn a language, let alone try to like design it and think about everything that goes into a language. I can't imagine doing that.
I can't imagine either. I don't even like there's like a whole bunch of other people who make like core contributions to the Julia language itself. And I don't even do that. As I do it a little bit, but yeah, it's incredible. It's crazy.
So I guess my question is just like, how did you get introduced to the Julia, and like what motivated you to contribute to I guess the design of it?
Yeah, it's a great question. So I happened to join a team in 2018, the end of 2017, early 2018, that was using Julia at NASA. And I had never used the language before, had any exposure, and it just happened that the team that I joined was using it, and I had I don't want to say opportunity because I didn't really have a choice. I had to learn Julia, had the opportunity to learn the language, start making contributions, and all that stuff. And it was a formative time in the Julia ecosystem because Julia 1.0 had just come out. So there was a lot of breaking changes from the old version to 1.0. So I basically spent the first 6 months of my internship at NASA helping rewrite some of the modeling and simulation code that we had to use Julia 1.0. And the team that I was on is and was building the traverse planning tool for the upcoming NASA Lunar Viper mission. So we're sending, for the first time in a really long time, a rover to the moon, specifically to look at the ice caps and try to drill for ice. And the actual traverse that the rover is taking, like the path it's taking from when it landed to the end of the mission, was wholly determined by the software that the team that I was on at NASA wrote, all using Julia, which is super cool. So you can start to think about all the impact that things like this are having. And the team that I was on made that decision because it's actually a really computationally difficult problem to find these optimal traverses. And it would have taken, like, the simulations took days in Julia, and if we were using another language, it would have taken like a week to run one simulation, which you can imagine is a limiter on how well you can solve a problem if it takes that long.
Yeah, I mean, that's really quick. It's kind of surprising to me that NASA would use Julia when it was just released, and rather than like let's say PyTorch or some other language that's already been implemented for years.
Yeah, and a lot of the reasoning was because the state-of-the-art tools for this decision-making framework, a mathematical decision-making framework called POMDPs, which allow you to represent real-world environments and then simulate actions and then the reward cycle. It's similar to reinforcement learning if folks are familiar. Like MDPs and POMDPs are very close to the reinforcement learning space. And again, the state-of-the-art POMDP and MDP tools were written in Julia at the time. So you could just, everyone who was doing research on POMDPs and things like that were using Julia, which was a lot of the reason why those teams at NASA were doing it. Also, the teams at NASA were involved with that Stanford lab where they were developing a lot of the technology. So lots of interplay there. But yeah, I agree with you. It's crazy that they made a bold bet on Julia at NASA as well.
Well, looks like it worked out.
Yeah, it's super exciting. It definitely did work out.
Okay, we have one question in person.
Yeah. Can you hear me back here, or do you want me to close it?
I think you can hear me.
Yeah. Hey, Logan, can you hear me?
Kind of. It's very faint, but I'll try to listen.
A little bit closer. Sorry.
All right. Hi, Logan. Hi, my name is Joey, and hey, how you doing? So I have a quick question, primarily on still the whys of Julia. So as of right now, I am the tech lead and project manager for a data science project for the Computer Science Society, where we are going to be wrangling historical data of climate change and using this data to make future predictions using ML models and artificial intelligence. Python already has several libraries and frameworks such as PyTorch, TensorFlow, we have Seaborn, Pandas. All of these libraries are already available to us. That's tried and true based on past and historical projects of artificial intelligence and machine learning. I'm still not convinced on why Julia would be the proper path to get into if we already have these packages available for us that's already workable and has been proven to be sufficient.
Yeah, Garrett, it's a great question. And I think it comes down to the details matter here. And I think it really depends. So what the general statement that I'll make is if you're specifically doing like PyTorch, for example, if you want to do like traditional deep learning at a production level, PyTorch is the tool that you should be using to do that. Like I won't misrepresent the ecosystem for Julia and say that it's better in Julia. It's not. Like PyTorch is supported by Facebook and tons of other Fortune 500 companies that are putting in millions of dollars to the development of that package. So if you want to do deep learning stuff, it's better to do that in PyTorch for the most part. There are specific, like if you want to do the state of the art climate modeling that academic institutions and things like that are trying to do today, that infrastructure is actually probably better in the Julia ecosystem because they're not doing like traditional deep learning, which is what PyTorch would be used for. It's a lot of like scientific machine learning, which is a whole nother ecosystem. So it really depends on the space that you're in and also like the production requirements. Like for you doing this project, you might not have any like, if it takes, a few hours to run a simulation or something like that, or train the model, you might not really care that much, but you could start to think about, some engineer at Facebook or Apple or Google who's being paid $300,000 a year. And if you make them sit there for 3 hours and do something and do nothing while their model is training, because that's what the computer is being used for and it can't do anything else, like it actually becomes a huge cost saving to make a switch to a different language that's more computationally efficient, because now that engineer can train their model in 10 minutes and they can get back to actually working and not sitting around doing nothing. And I worked at Apple as a machine learning engineer, and I can say that like that is the kind of stuff that the challenges that engineers have in the real world, which is it takes time to do a lot of these things. So if you have a more efficient tool and you can more efficiently solve problems, you can be better at your job. I don't know if that answers the question, Joey, but
Yeah, I think that's a pretty good answer. I'm also very aware that that Julia also has the like the speed and capabilities of like what C++ is, but the syntactually wise, it looks like Python. Would you think that Julia would be a great first language for those who are just coming into computer science?
I do. I actually do. I think that there's a lot of work that myself personally needs to do and the ecosystem needs to do in order to make that case more clear. But I think the fact that you can learn Julia and have that computational efficiency right out of the gate is an incredible reason that you should be doing it. And it also solves like a bunch of these like really like annoying problems like the package installation. Julia is also, for better or for worse, one-based indexing. It's not zero-based indexing, which I don't care where you fall in this argument. When people learn how to count as a child, nobody learns how to count from zero. You start counting with one. You only learn zero-based indexing when you study computer science. And for like normal people who don't have that background, don't have a traditional computer science background, it's always very confusing to think about zero-based indexing. So one-based indexing is another reason that I think Julia is well suited for people starting out in computer science.
Do you also, sorry, I know I have like a few questions and such.
No, it's all
But
good.
do you think that, because I know that the stable release of Julia was, I think, remind me, it was like maybe like about a month ago or so. The official stable release of Julia was very, very recent, right?
No, so the first official stable release of Julia was Julia 1.0 in 2018, which is still relatively recently. But there was a new stable release a few months ago, but it's just it was replacing the previous stable release, which was like Julia 1.6 or something like that. So we're on like a 3 to 4 month release cycle for new versions of the language, but the stable release is going to stay the way that it is for like the next 3 years, which is, I think, Julia 1.7 is the stable release right now.
So do you think that the packages are going to mature just like how Python's packages have matured?
That's like one of the biggest indicators that people look at today to like compare the Julia ecosystem with other things is the number of packages is a big indicator, and the number of packages in the Julia ecosystem, and I mentioned this right at the beginning of the presentation, but is getting close to the number of packages that are in the R ecosystem, which is like, I would say number 2 right now. It's Python, R, and then Julia in like the data science computational programming space. So yeah, all of those packages are going to continue to mature. Just like I mentioned, data frame, CSV, all these packages in the Julia ecosystem, which are like the pandas and all those equivalents, are already faster. So the benefits of being a Julia developer just continue to increase because those packages continue to mature and get more computationally efficient, and you just end up being able to solve problems a lot faster, which is cool.
Awesome, great. Thank you. I really do appreciate it, Logan.
Yeah, sure. Great questions. And the other piece of this too that we haven't touched on before, but like part of the motivation for me these days is I see the Julia ecosystem being like also an amazing career opportunity. Like there's just so many, like you can think about it, like there's so many problems that people haven't solved. There's so much important documentation and articles and contributions that people haven't made yet because the Julia ecosystem is still maturing. So you have a real opportunity. Like I think I got really, really lucky that I got involved in the Julia ecosystem in 2018 and have been able to make these contributions over the last 4 years. But there's still so many opportunities for people who are getting involved today. And like the reality is you don't have those opportunities in the Python ecosystem or the R ecosystem because of how many people are in there. Like you're just not competing, but like the low-hanging fruit has already been accomplished by everybody else. So there's not, those opportunities aren't there. And I think that's what keeps me really actively engaged in the Julia ecosystem is there's so many things that have to happen that are really, really impactful and also aren't like, you know, they're not like insane things that have to happen. They're like actual manageable things like make a better introduction to Julia course, or like the question, Johnny, like make resources for people who are learning Julia who don't have a computer science background yet. Like all that stuff is low-hanging fruit. That's super high impact. And it's what keeps me up at night is just thinking about all those opportunities that people need to go and execute on.
So you'd say that Julia would probably surpass Python in the data science umbrella eventually.
See, that's the tough thing is that like success for the Julia ecosystem does not require that we surpass Python. Like the reality is Python is the most successful programming ecosystem ever. And it doesn't mean that we have to be at the same level as Python in order for Julia to be successful. Like at the end of the day, we're all going to win. It doesn't need to surpass Python. If it does, that's awesome. If it doesn't, that won't be a hindrance in my mind on the success of the ecosystem. Like people are getting value today solving these problems. And if we can get more people to get value and solve the problems that they're having, that's a huge win. And whether it's 10% the size of Python or 50% the size of Python, like whatever the number ends up being at the limit, I still think it's going to be a big success.
So Julia is like another tool for Python. They can work together and such.
I do think that that's true as well. And that goes back to the interoperability point. Like you can keep using Python, you can keep using your existing Python infrastructure and just build on top of it using Julia. So whatever the benefits are that Julia provides, do the stuff in Julia there's benefits, and keep using Python for the other stuff where there's maybe more mature packages or something like that.
All right, cool. I appreciate it, Logan. Thank you.
Yeah, sure. Great questions.
Any questions in the Zoom? Last chances. No, I think that's it then. Oh wait. Oh,
I was just going to leave this this link up for folks if they're interested. You want to learn more about actually like making contributions to the ecosystem or getting your hands dirty doing stuff, check it out. Feel free to ping me on Twitter or LinkedIn or by email if I can be of any help. But yeah, thanks everybody for listening, and good luck with the rest of the semester. And yeah, feel free to ping me.
Sorry, one quick question, Logan.
Sure.
In the chat, I don't know if you can see it.
What do you think any major changes in Julia are headed? Simon, can you provide just a little bit more context for me here? I'm not sure if I understand completely.
Question is a little confusing. Simon, you have 10. Oh,
Oh, like what do I think will change between this stable release and next, if that makes sense? Yeah, that's a really good question. So I just wrote an article the other day about why Julia 2.0 isn't coming anytime soon. So right now, the current development release of Julia is Julia 1.8. And basically the gist is that the like they're going to continue to fix a bunch of stuff in the ecosystem, make things faster, pre-compilation, some specific things, Simon, related to creating executables. So like .exe files, which languages like Python do really well right now, and Julia doesn't do a good job of supporting the creation of executables. So there's work that's happening in that direction, work that's happening to make pre-compilation faster, a bunch of other stuff faster with the compiler. That tends to be a lot of the, I would also encourage you to read some of the release blog posts, which talk in depth about all the changes that have happened. And it's an incredible amount of stuff. I'm like, I don't understand how people have time to make as many contributions and make stuff as great as they do in the new releases. But the next stable release will be, probably won't be for a few years. So I have no idea. I'm hoping that things will be a lot better. Like the language will be easier to use and better and faster in a couple of years. But I don't think that there's any like specific things that come to mind as far as what needs to be fixed or the like. There's lots of small things that will add up to a huge impact, hopefully. But read that article and let me know what you think. Just Google Julia 2.0 and it should show up. Yeah, awesome. Great question. Any other last minute questions before we wrap up?
don't think so.
Cool.
All right, thank you so much, Logan.
Yeah, this was great.
Really
Thanks for
appreciate
having me. And again, feel free to shoot me an email or message on Twitter or the like.
Yeah, I'll provide everyone with your LinkedIn. All right, thank you again.
Yep. Take care, folks. See ya.
Thank you. Bye, Logan.